Assalamualaikum and salam sejahtera. Hi guys, welcome to your final chapter for SK0024 Analytical and Organic Chemistry. In this chapter, I will explain about polymers. In this chapter, you will learn about polymers, the physical-chemical properties of polymers, nomenclature of polymers, types of polymers, the application of polymers, and about plastics. At the end of this chapter, student will be able to first explain the physical and chemical properties of polymers, second, naming the polymer compounds, third, classify the polymers, and fourth, explain the application of polymers. Before I further explain about the polymers, we should know about the definition of polymers. In Greek, polymers can be divided into two definitions. First, poly means many and meros means part. If we combine these two, it comes to the polymers, defined as many parts. Scientifically said, polymers is a giant molecule with molar masses ranging from thousands to millions. Polymers form when the structural unit, known as repeating unit, called monomers, covalently bonded together. In other words, many monomers will polymerize to form the polymer. How a polymer form? Can any chemical substances act as monomer? How to calculate the mass of polymer? And what is the physical and chemical properties of polymers? These are questions that always been asked by students about the polymers. So, to answer the questions, students should understand first about this one. First, the essential requirement to qualify as monomer. To become a monomer, the monomer must possess two or more bonding sites which can be linked to another monomer. Second, monomer should have the number of bonding sites that referred as the functionality of this monomer. And then the third one, the monomer should has at least bifunctionality. It means that it should have either one double bond or two reactive functional groups. For example, ethylene. Ethylene can become the monomer because it contains the double bond. The double bond will open up the bond and become two bonding sites which can be linked to another monomer. Second example, the ethylene glycol. This ethylene glycol contains two reactive functional groups because it has two hydroxyl groups. This hydroxyl group will become the bonding site that can be linked to another monomer to form the polymers. Then, students should know about the reaction that can produce the polymer chain. So, which reaction will produce the polymer chain? The first reaction is the reaction between two compounds which each contain monofunctional group. For example, the reaction between acetic acid and ethyl glycol. The reaction is complete in one step, leading to the formation of ethyl acetate. If you can see in the acetic acid and ethyl glycol, both compounds contain only monofunctional group. In acetic acid, it has C double bond O, H, become as a bonding site, and then for ethyl alcohol, the hydroxyl group will become the bonding site for the ethyl alcohol. Then the reaction of polymer, the reaction will happen between these two bonding sites to form the ethyl acetate. The second one is the reaction between two compounds that contain monofunctional group and the other compound contain bifunctional group. For example, the reaction between ethylene glycol and acetic acid. The reaction complete in two steps. The first reaction is the reaction that lead to the formation of monoester. Okay, so in this ethylene glycol, okay, if you can see, the ethylene glycol contain two bifunctional group because it contain the two reactive groups. Okay, meanwhile the acetic acid only contain the monofunctional group because it has only one side of the hydroxyl group. Then the ethylene glycol and acetic acid will react to form the monoester. Then further reaction of monoester with acetic acid will yield the diester. So from the monoester will react with the acetic acid which has a monofunctional bonding site to form the diester. Since the diester do not have any more reactive functional group on its other sides, no further reactions take place. Thus, no polymer chains are resulted. The third reaction is the reaction between two compounds each contain bifunctional group. For example, the reaction between ethylene glycol and malonic acid. The addition of each of the monomer to another continues till the concentration of one of the species is depleted. It produces a high molecular weight polymers from these bifunctional monomers. If you can see here, both compounds contain bifunctional group. The ethylene glycol contains two hydroxyl group and the malonic acid contains two carboxylic acid group. So when it reacts, it will form the monoester first. Then the monoester can further react with another malonic acid or ethylene glycol to form the diester, and the reaction will continuously occur until the concentration of one of the species is depleted. It means that in this reaction, it will form the polymer chain. From the previous explanation about the reaction, it can be summarized with this diagram. So the reaction between monofunctional molecules, it will just lead to the one reaction only, and the reaction between mono and bifunctional molecules, it can lead to two steps of reaction, and it only form the small molecule, while the reaction between bifunctional molecules, it will form the linear polymer molecules. Next, students should understand how to calculate the molecular weight of polymers. Let's say students are given the structure of polymer PVC, and this is the molecular structure of PVC, CH2, CH2Cl. Then first step is student must identify its monomer. So based on the molecular structure of PVC, we can identify that the monomer of the PVC is the vinyl chloride, CH2CHCl, which means that monomers of vinyl chloride will react with each other to form the PVC, polymer PVC. The next one is students should determine its degree of polymerization. Refer to the molecular structure. 1000 of this number refer to the degree of polymerization. It means that there are 1000 of vinyl chloride form the PVC polymer. Next, to calculate the molecular weight of this PVC, students just multiply the molecular weight of monomers with the degree of polymerization. So in this case, the molecular weight of monomer, which is the vinyl chloride, 62.5 times with the dP of the polymer, which is 1000. So 62.5 times with the 1000, so that you can get the molecular weight of polymers, that is 62,500. And then maybe from this molecular structure of PVC, student will be asked about the CRU. So what is CRU? CRU means the constitutional repeating unit. So based on the molecular structure of the PVC, the constitutional repeating unit CRU of this PVC is this one. About this one, the repeating unit. Okay, CH2CHCl. So which means it will continuously bonded with same structure until 1000 to form the PVC. So this is how to calculate the molecular weight of polymer and identify the CRU of polymer. Next, we move to the physical and chemical properties of polymers. First, we look into the physical properties of polymers. First, as chain length and cross-link increase, the tensile strength of the polymer increases. So if you can see here, as the polymer chain increase, it will increasing the molecular formula and weight of the compound. Thus, it will also increase the tensile strength of the polymers. And based on this structure, the comparison between linear, branch, and cross-link and network, the cross-link and network give high tensile strength compared to branch and linear due to the complicated of its structure. The second one is polymer do not melt. However, they could change state. For example, from the crystalline to semi-crystalline, it based on the chemical structure of the compound. Next, we move to the chemical properties of polymers. Polymers is enabled with hydrogen bonding and ionic bonding, resulting in better cross-linking strength. If you can see, some of the polymers can create or can form a hydrogen bonding between its polymer to form the cross-link strength. And then it also can create the ionic linkage between the polymers to produce the better cross-linking polymer with high strength. Next, the dipole-dipole bonding side chain enable the polymer for high flexibility. And the polymer with van der Waals forces linking chains are known to be weak but give the polymer a low melting point. We continue with the nomenclature of polymer. For the nomenclature of polymer, the naming of the polymer depends on the monomer of this compound. For example, ethylene. Okay, for example, ethylene, when it forms the polymers, we can name the polymers as polyethylene. And then another example is propylene. When the propylene form the polymers, it can be named as polypropylene. Same as styrene. When the styrene become the polymers, we can name the polymers that produce as polystyrene. Okay, some of the polymers can be named as trivial name. For example, poly 1,1-dimethyl-ethylene. We can name the polymer as the polyisobutylene. This name depends on the structure of the monomers in the polymer. Another example, poly 1-methyl-1-butynylene. This polymer can also be named as polyisoprene. Another example is poly 1-butynylene. Okay, poly 1-butynylene also can be named as polybutadiene. As I said, the trivial name for certain polymers are given based on the molecular structure of the polymer itself. And then this is another example that you can go through one by one.